The camshaft is critical to the basic function of an engine. Comprised of two distinct parts, the cams and the shaft, the camshaft is the element that enables valves to open. As the shaft rotates, the egg-shaped cams, or lobes, push the valves open in sync with the crankshaft gear. Identifying the camshaft. In modern overhead cam, OHC, engines, the camshaft is located in the cylinder head. Single OHC, SOHC, engines have one cam per bank, usually mounted between the valve stems. Rocker arms transmit SOHC movement to the valves. Dual OHC, DOHC, engines have two cams per bank, usually directly over the valve stems, one for intake valves and one for exhaust valves. Force is transmitted directly to the valve. An I4, 4-cylinder, SOHC engine has one camshaft, while a V6 or V8 SOHC engine has two. An I4 DOHC engine has two camshafts, while a V6 or V8 DOHC engine has four camshafts. Overhead cam engines have 3 to 5 valves per cylinder, but usually 2 intake valves and 2 exhaust valves. Older engines and a few newer pushrod engines have a single camshaft in the cylinder block. Long metal pushrods transmit camshaft movement to the rocker arms, which transmit that movement to the valves. Pushrod engines usually have 2 or 3 valves per cylinder, usually one intake valve and one exhaust valve. The typical camshaft is milled from a rough-formed cast steel blank. Some performance and custom camshafts may be milled from a solid steel block. How camshafts work. As the camshaft rotates, the cam lobes move up and down. In DOHC engines, every rotation causes a single cam lobe to push the valve down, opening it into the cylinder. Similarly, in SOHC and pushrod engines, the cam lobe pushes on the rocker arms, or pushrods then rocker arms, opening the valve. As the cam lobe rotates further, the valve spring forces the valve back up, closing it. The camshaft is usually connected to the crankshaft using a timing chain or timing belt. In some pushrod engines, timing gears may also be used. The camshaft gear has twice as many teeth as the crankshaft gear, which allows it to rotate at half the speed of the crankshaft. The camshaft has 4 distinct strokes: intake, compression, power, and exhaust. Common camshafts are made to match typical operating characteristics and may accentuate highway cruising efficiency or low-end power. Similarly, valve lift refers to the height of the lobe in relation to the center of the shaft, which determines how far the valve opens. On fixed camshafts, this is not adjustable, but there are circumstances at which the engine might breathe better if only the valves could open a little more. Also, a fixed camshaft might open the intake valve 10 degrees before TDC, BTDC, and close it 5 degrees after bottom dead center, ABDC, and open the exhaust valve 15 degrees before bottom dead center, BBDC, and close it 5 degrees ATDC. This is referred to as valve opening duration. This works well on average but doesn't excel in any one driving situation. Specialized camshaft functions. Timing is important. Valves must open and close at specific intervals in relation to cylinder position. For example, as cylinder number 1 is coming to top dead center, TDC, on the exhaust stroke, the camshaft is opening the intake valves and closing the exhaust valves. At the same time, cylinder number 3 might be reaching TDC on the compression stroke, so the camshaft would leave those valves closed. Camshafts fitted with variable valve timing, VVT, use hydraulic actuators to advance or retard valve timing in relation to crankshaft angle. VVT enables high-speed efficiency or low-speed power. Using specialized variable valve lift, VVL, camshafts and computer-controlled solenoids or hydraulic actuators, the ECM can select between 2 valve lift options, depending on driver demand. On vehicles with direct fuel injection, some diesel engines, and most gasoline direct injection engines, the high-pressure fuel pump, HPFP, is driven by a lobe on one of the camshafts. Common camshaft problems. Because the camshaft is a solid steel component, it isn't prone to wear or breakage. In most engines, other parts will wear out before the camshaft. Still, there are a few common camshaft problems that might arise. Worn cam lobes, also called wiped out or flogged, refers to cam lobes that have been worn down. Worn cam lobes won't open the valves as much as intended, leading to poor engine performance and cylinder misfiring. If this affects the HPFP, insufficient fuel pressure will lead to higher emissions and random misfiring. Worn lifters do not refer to an exclusive camshaft problem, but can be driven by the camshaft. A worn lifter won't lift the valve as much as INTENED, if at all, and is typically heard as a clattering or tapping in the valve cover. Broken camshaft refers to catastrophic failure of the camshaft. This could be a manufacturing defect or be caused by the camshaft seizing. In pushrod engines, a broken camshaft could significantly damage connecting rods, cylinder block, pistons, or the crankshaft. In interference engines, a broken camshaft could damage the cylinder head, valves, or pistons. All three of these problems are caused by lack of proper engine maintenance. Prevent camshaft issues by getting regular engine oil changes with a quality oil, adhering to manufacturer recommendations regarding oil change interval, oil type, and oil viscosity, and avoiding engine overheating.